This is the demonstration video for standard load balancer. In previous video we talked about the comparison and difference between basic Azure load balancer and standard. We have covered the entire theory and the demonstration of basic load balancer already. Today it's about standard load balancer's demo. Hello everyone, my name is Arun, and today I have made a scenario with the help of which we will be creating both internal and external standard load balancers, and we'll see all the components which are actually the features that make the basic load balancer a standard, because we have already covered everything in the basic. And in this scenario, in this demo, we'll be seeing only the standard features in particular. Okay, so what is the scenario? In scenario, we have this VM. I'm logged in right now. If I write host name, you can see it's test VM3. Okay, and the IIS is configured here. If I do start process, I explore. Okay, and localhost. Okay, I did this wrong, but I can type here localhost, and you can see the IIS is configured, and this is VM3. Let me minimize this one. And one more thing, on the same page, if I do my blog, I can browse. Internet is working. Okay, you do google.com, it's working. All right, you can do YouTube, it's all working. The internet is working fine. Okay, let's minimize, and now we are creating the internal load balancer. Okay, and we'll write the resource group name, location. We all know about these information already. Now the type says internal or public. Public is actually the external, where you would have the public IP assigned to it, that to be standard for the standard load balancer. But we need internal, so it's internal. Basic, no. Standard SKU, that's the demo. Okay, and this is talking about the secure by default. We already talked about these. Virtual network, that's the virtual network, that's the subnet. And IP assignment, for private we can have both static and dynamic. For public we can only have static, because that would be standard IP, and standard public IP is always static. So let's review, and it's validating right now, and create. We do have video created in the same series, difference between basic IP address and the standard IP address as well. You can go and check it out. That would be good to watch, good to know information is there. So it's in underway right now. Okay, let's go to the resource. You won't find anything new here. It seems everything just like basic. We do not even have the outbound rule here that we will find in the external or public standard LB. Okay, let's see the front end IB. This IP came from the subnet we chose. Backend pool. Now here we know there is a difference in the backend pool. In basic there are only few, in standard there are so many. Let me type here backend, our VM3 virtual machine, IP configuration, add. Okay, and you can see it is saying If your VM has a basic public IP address, you cannot add it behind the standard load balancer. You should not have the IP address, or if you must, then it should be standard. Okay, so it's deploying right now, it's validating. Okay, so the deployment is successful. The backend has been added at the backend pool. Now you can see once the backend is added, we must have lost the internet connectivity of the backend pool. This is something that lots of people encounter. We do not lose the internet connectivity in the basic load balancer, but we do in the standard internal load balancer. And we'll fix it with the help of public load balancer, and we would have both the demonstration and fixing this issue as well. Okay, let me minimize this. Health probe is same as per the basic. The only thing is new here is the protocol. We got one more. Rest is same, so let's click OK. Nothing changed in the NAT rules. In the load balancing rules, we will find HA ports. Yeah, right here. Okay. Now, let's go ahead and create the load balancing rule, LB rule. And this is the HA ports, backend pool session persistence. We don't need it right now, but we have already covered this in the previous video, but let me talk about a little more on HA ports. Well, Azure Standard LB helps you load balance TCP and UDP flows on all ports simultaneously when you're using internal load balancer with the help of HA ports. This HA port can give you an edge, okay? And also the HA ports load balancing rules help you with critical scenarios such as high availability and scale for network virtual appliances, NVAs, inside the virtual network. And this feature can also help when a large number of ports must be load balanced. We know there are organizations which are too much into security, and they apply lots of NVAs, and they want every traffic to go through the NVA, from whether it's internal and or external, it should come through the NVA. So this standard internal load balancer can help us in doing or achieving that task when we have multiple NVAs behind the load balancer. Okay, so you can use NVAs to help secure your Azure workload from multiple types of security threats. And when you use NVAs in these scenarios, they must be reliable and highly available, and they must scale out for demand. You can achieve these goals simply by adding NVA instance to the backend pool of your internal load balancer and configure an HA port load balancer rule. And you can also use HA ports for applications that require load balancing of a large number of ports. Okay, but this is the demo. We are not doing such kind of thing. We are just going through the features and components which are new and fixing the internet issue. All right, rest all is covered already, and we have TCP reset. You can enable it as well or let it be disabled. It doesn't matter anymore. And you can, this is for outbound rules. Yes, we will create the implicit outbound rules. Public IP address specified. That we will do with the help of public load balancer. Now the TCP reset, a little something on TCP reset. Well, how do I explain this? To create a more predictable application behavior for your scenarios by enabling TCP reset on idle for a given rule. Load balancer's default behavior is to silently drop flows when the idle timeout of a flow is reached. Enabling this feature will cause load balancer to send bidirectional TCP resets on idle timeout. This will inform your application endpoints that the connection has timed out and is no longer usable. Endpoints can immediately establish a new connection if needed. Okay, that's all about these features. Let's click OK. Now the load balancing rule is configuring. This part is done. Don't have internet connectivity. Now let's go ahead and create the public load balancer. We'll add the same VM and in the backend, and we'll create the outbound rules. Let's go to the load balancer, resource group, name, public LB, location, North Europe, standard, public. Okay, and you'll see use existing. Okay, oh, got it. This is the existing, and all right, this is static public IP. We talked about it. Okay, now it's creating the public load balancer. Validate it. Let's create. Even if you see the management operations, basic load balancer was taking too much time while creating the load balancing rules or NAT rules or any other deployment as compared to the standard load balancer. All right, cool. All right, so it's been done. Let's go to the resource. That's the public load balancer. That is our front-end public IP address. And you see we got the outbound rules. Let's add the same VM as the backend and fix the pool. Give any name, virtual network, same VM, IP add. Now we will create the health probe. We don't need to load balance. We only need the outbound rules. Load balance is exactly the same as internal or the basic, but we would not have the HA port information. Or we'll say it. We'll go through the options, no problem. Cool, so it's been added, it's deployed, health probe. It's the same, just creating. Only the HTTPS is the new thing. Let's click on the load balancing rule. You see we do not have the HA port here. And we have this create implicit outbound rules. If you click on no, you will lose the internet connectivity as well if you are using the public load balancer. We can see that in our lab. So let's not create this right now. Let's create the outbound rules. Add. Now you can give the name outbound or anything that you like. That's the IP address we want to use for the outbound. All, let's say all. And that's the idle timeout. You can increase it or decrease it. That is fine. Let's keep it 15. TCP reset is enabled here. Let's select the backend pool. Port allocation, it's manual or default number of outbound port. Let's keep manual. Okay. And port per instance. And ports, let's say 10,000. Okay. Maximum number of backend instance 6. That's what we did. You can choose the default as well. So let's add it. Okay, it's validating right now, and you can see what all things we talked about in the differences and the comparison. Almost all of the features and the components we have touched in the demonstration. And after creation of the outbound rule, our VM, which are actually behind the internal load balancer and lost the internet connectivity, now would be able to access the internet with the help of this public IP addresses. Okay, so it's been done. Let me refresh. We got the outbound rule. This is our backend VM. Let's get back to the VM and see, refresh it, if we can access the internet. There we go. We can access the internet. Let me try to access my blog. Yes, we can see that as well. Okay, wonderful. Now let's go to the internal load balancer. Okay, I don't know whether I can show you that or not. Let me delete the backend. Okay, or let's delete the entire load balancer. That's fine. We have seen what actually we were trying to see or demonstrate. Okay, and you know, when we create the VM, let's suppose I'm creating a VM here, and you can also put that VM behind the load balancer, that and there. Load balancing, you can see when you create the VM and you already have the load balancer in place, you can directly put behind the load balancer during the creation of your VM. That's what you can do also. Okay, now this is our, okay, now let me delete this rule as well. Okay, this is the, I'm sorry, the outbound rules. Let me delete the outbound rules. Okay, now we have only public, let me go to the load balancers. It's still there, not delete. Oh, it's deleted, not found. Okay, so we only have the public load balancer now, and in the backend we have the same sorry, this is the public IP. But in backend we have the same VM3 option, VM3 virtual machine as the backend health probe. Now go to the load balancing rule and load balance it. Okay, let's do rule 1. uh, Before we do that, let me check one more thing. Did we move it from the outbound rules? So there is no outbound rules as well. Okay, let's create the load balancing rule. All right, all remains the same, and this is create implicit outbound rule is yes. So that means this will create the outbound rules for the backend VM, and it would not hamper the internet connectivity for us. That's what I hope. Let's go. Try refresh. We still have the internet connectivity. Go to YouTube. We have the internet connectivity. Cool. Now let's delete this again and create one more rule 2. Everything is same. Let's go create implicit outbound rule. Say no. Click OK. All right, it's saving the rule. Let's see what happens once the rule is saved. Refresh. Okay. No. This was the, okay, now it's waiting. It must have lost the internet connectivity because implicit outbound rules been not created, and these are saved now. Okay, see, we must have lost the internet connectivity. It's just browsing, page cannot be displayed. Okay, you see what I was talking? Cool. No, Okay. Now you can create the outbound rules with a different public IP address. If you add one more public IP address here, and you can create the different outbound rules. Means like the traffic is coming from a different IP address and going from a different IP address. You can do that as well. Okay. So that's all about it. We just checked so many things in this demonstration, also fix the internet issue. And that's all about it. Well, thank you for watching. You have a good day.